Welcome back on the class of design of concrete structure. So I hope you all are safe and doing well. So in the last class I have discussed about the deflection criteria, and I told you that for a cantilever beam, when our span is less than 10 meter, so the span by effective depth ratio should be 7, and similarly for a simply supported beam it is 20, and for continuous beam it is 26. Once the span exceeds 10 meter, then I told you that for simply supported beam and continuous beam, L by D ratio is 20 by 10, 20 into 10 by span, and for continuous it is 26 into 10 by span. So today I am going to discuss another topic of design of slab, that is another IS codal provision, that is how much we have to take the minimum reinforcement in a slab, and after that I will design how to design the slab for one-way slab. So for a slab, minimum reinforcement is equal to 0.12% of capital B into D, when HYSD / TMT bars are there. Similarly, minimum reinforcement is 0.15% of B into D when mild steel reinforcement are used. So minimum reinforcement in slab, what we have, I have suggested minimum reinforcement is 0.85, in beam minimum reinforcement is 0.85 times BD by Fy, but in slab minimum reinforcement is 0.12% of BD and 0.15% of BD when our HYSD or mild steels are there. Similarly, maximum diameter of bar. So maximum diameter of bar is 1/8 of total thickness. So these are the IS codal provision. Let us assume if 100 mm thick slab, so maximum diameter we can provide. Maximum diameter is 100 by 8, 12.5 mm. So we can use 12 mm may be used. So maximum diameter in a slab is 1/8 of the total thickness can be provided. Nominal cover, another topic that is very important. Nominal cover. So minimum depth, design depth, of concrete cover to all type of steel reinforcement including links. So minimum clear cover code suggests that depends on the exposure condition. So if this is slab, so nominal cover is, this is nominal cover. So code suggests nominal cover. So according to IS 456 exposure condition, minimum nominal cover, minimum grade of concrete. So that depends on the exposure condition, how much we have to take the nominal cover. So if the exposure condition is mild, so nominal cover we have to take 20 mm, and for the minimum grade of concrete is M20, and this prevented from weather / rain. Similarly, second exposure condition is moderate. So in moderate, minimum nominal cover is 30 mm and minimum grade of concrete is M25. Sheltered from severe rain, exposed to rain, and third is concrete continuously kept under water. Concrete continuously kept at water. Third exposure condition is severe. In case of severe condition, nominal cover provided is 45 mm and minimum grade of concrete is M30. So in this alternate wetting and drying completely immersed in seawater. So severe means alternate wetting and drying and completely immersed in sea water. Very severe. So in case of very severe, minimum nominal cover is 50 mm and the grade of concrete is M35. Exposed to seawater, severe freezing and thawing. Similarly, last exposure condition is extreme severe condition. So this is very important for the examination point of view. So extreme in minimum nominal cover is 75 mm and grade of concrete is M40. Member subjected to chemicals. In the water, and the second one is member in tidal zone. So these are the exposure condition we have seen. For different exposure condition, minimum nominal cover is taken and a minimum grade of concrete. So dear learners, till now we have seen that how to take the minimum area of steel in case of slab. So code suggests that minimum area of steel or reinforcement in case of mild steel is 0.15% of capital B into capital D, where capital B is the width and capital D is the overall depth. And in case of Fe415 or Fe500, we have to take minimum area of steel is 0.12% of B into capital D. Similarly, code suggests the maximum diameter in a slab can be taken as 1/8 of the total of the thickness of the slab. So minimum diameter we have to take 1/8 of the thickness of the slab. And after that I have discussed nominal cover, how we have to take the nominal cover, so that depends on the exposure condition. So I told you about the 5 different exposure condition, that is mild, moderate, severe, very severe and extreme. And in that condition court suggested that how we have to take the minimum nominal cover, that is 20 mm, 30 mm, 45 mm, 50 mm and 75 mm, and according to that we have to take the minimum grade of concrete. After that I am going to discuss about the how to design of one-way slab, and for the design of one-way slab what are the various parameters we have to calculate, and with the help of that parameter we will design the one-way slab. So the minimum clear cover for different member like slab, beam, column and footing. So the first one is slab and the different exposure condition like mild, severe, very severe, or so in case of slab we have to take the minimum nominal cover is 20 mm when our exposure condition is mild. Similarly in case of severe it is 45 and very severe or extreme 50 mm we have to take. Second one is beam. In case of beam we have to take minimum nominal cover is 25 mm, 45 mm and 50 mm. In case of column it is 40 mm, 45 mm and 50 mm. And the last one is foundation or footing. So in case of footing minimum cover in case of mild exposure condition is 50 mm, 50 mm and 50 mm. So these are the codal provision for different members like slab, beam, column and footing, how much we have to take the minimum nominal cover. So now I am going to start how to design one-way slab. So design of one-way slab. So design of one-way slab. This is if this is a span. So if a slab is supported over two opposite supports, it is always a one-way slab. So if a slab is supported over two opposite supports, it is always a one-way slab. Similarly, if let us assume second condition for the one-way slab is very important condition, that is if Ly by Lx, that is longer span by shorter span, and this ratio is exceed 2, then it is called one-way slab, where if I make if this is Ly and this is Lx, so if Ly by Lx greater than 2, then we have to design as a one-way slab. If Ly by Lx less than equal to 2, then we have to design as two-way slab. So where Ly and Lx is the longer span and shorter span. So design of various design steps. So design steps for one-way slab. How to design one-way slab? So firstly I have to calculate step first, load calculation. Load calculation. So in load there are various load. First load is live load. So live load we have to computed if live load is given into 1 into 1. Let us assume it is W1, where WL is the live load in kilonewton per meter. Similarly, second one is floor finishing. Floor finishing is nothing but thickness of floor into 1 into 1 into 24 kilonewton per meter cube. So it is W2. And the self weight of slab, is equal to thickness of slab into 1 meter, and unit weight of reinforced concrete is 25 kilonewton per meter cube. So this is the total load. Total load acting on one-way slab is sum of W1 plus W2 plus W3. So factored load here can be computed. Factored load is equal to 1.5 times total load W. Step 2. So in first step we have computed the load calculation. So load due to dead load, live load, self weight and floor finishing. Effective span. In the second step we have to compute effective span. So effective span we know for a simply supported beam, already discussed in the previous class, for a simply supported, L effective is equal to clear span plus effective depth or clear span plus width of the support, whichever is less. Step third is we have to compute the maximum bending moment. So step 3, maximum bending moment as per type of slab. Step 4, depth required. So we know in the similarly what we have computed in the beam, same thing, bending moment divided by Q into B. So with the help of where here B is 1 for 1 meter design, slab is designing for 1 meter, so width, so it is B is equal to 1000 mm, and Q is the bending moment coefficient that depends on the different grade of steel. I have already discussed, that is 0.148, 0.138 and 0.133 FCK. Next step, so we have to compute the area of steel. Step 5 is area of steel, AST. So area of steel in limit state method, area of steel is in limit state method, AST is nothing but ultimate bending moment divided by 0.87 Fy into J into D. In working stress method, area of steel can be computed bending moment divided by sigma st into J into D, where J is 1 minus 0.42 K and K is neutral axis depth factor that will be different for the grade of steel, where in limit state method J is equal to 1 minus 0.42 K and where K is neutral axis factor, depth factor, and K value is 0.53, 0.48 and 0.46 for Fe 250, Fe 415 and Fe 500. Step 6, we have to compute distribution of bars. So distribution of bars, that depends on the grade of steel. So either 0.12% of BD or 0.15% of BD, that depends on the grade of steel. If mild steel is there, so we have to take 0.15%. If other grade of steel is there, so 0.12% we have to take. After that, I will check for the shear. Check for shear. So check for shear is compute the nominal shear stress. Tau V is nominal shear stress, that is factored shear force by B into D, and it should be less than tau C. If tau V greater than tau C, increase the depth of slab. If tau V greater than tau C max, slab is now step 8, check for bond. So we know that tau BD, design bond shear stress, is V by summation of A into J into D, or and step 9, check positive moment tension reinforcement. So we know that development length is less than equal to 1.3 m1 by V plus L0, where L0 is anchorage value. So these are the check we have to do in the design of slab. So dear learner, today I have discussed about the design of one-way slab, and we have seen the various design steps for the one-way slab. So I will recall you what are the various design steps. So the first step, we have to compute the value of load calculation, and load can be computed dead load, live load and floor finishing. After that, we have to compute the value of effective span. So effective span for a simply supported beam is clear span plus effective depth, or clear span plus width of support, whichever is less. After that, we have to compute the maximum bending moment, and step 4, we have to compute the effective depth. So effective depth can be computed as square root of factored bending moment divided by Q into B, where B is the width of slab, and for the design of one-way slab we have to take as for the design of 1 meter, so B is 1000 mm, and Q is the bending moment coefficient that depends on the grade of steel, and Q is computed 0.138 FCK, 0.148 FCK and 0.133 FCK. Once we compute the effective depth, after that there are various checks we have to compute. Like after that we have to compute the area of steel, and area of steel distribution of bar is taken as 0.12% of BD or 0.15% of BD. If there is a mild steel, so we have to take 0.15% of BD, and if there is a other grade of steel like Fe415 or Fe500, so we have to take 0.12% of BD. Once we have computed the area of steel, so number of bars can be computed. After that we have to check for the design of shear. So in the case of design of shear, we have to compute the factored shear force, and with the help of that factored shear force we have to compute the nominal shear stress, and this nominal shear stress should be less than the maximum shear stress of concrete, that depends on the grade of concrete only. After that we have to check for the development length, that is bond. So design bond shear stress can be computed as V by summation of O into JD, and with the help of that design bond stress we can compute the value of development length, and this development length can be computed as development length. So the check for the development length according to IS 456 is LD is less than equal to 1.3 M1 by V plus L0, where L0 is the anchorage value, that is the value of this L0 is suggested by the IS 456 2000. So in the coming class I will discuss some problems related to the one-way slab, and after that I will discuss two-way slab. So take care of your health and happy learning.